Hello students, welcome to my classroom. In this video, we are going to have a deep discussion about probability and the types of questions that you commonly see on a probability concept. So I will also discuss the important points that you need to remember for every certain type of question that you will see. So in this video, I have divided the types of questions into 4 categories. But before that, I will give you a little introduction. If you really want more in-depth introduction, you can watch my probability introduction video, the link for which I'll post in the description of this video. So basically, the meaning of probability, which is always in a math question denoted by the letter P, is given by the number of favorable outcomes divided by the total number of outcomes that you can have. So it's always usually given as a fraction, and any times you see the answer as a decimal, you can always convert that fraction to a decimal either by dividing or by just using calculator. So the types of questions that you will see on a probability concept are going to be, in this video, I'm going to deal with 4 major types of questions. So I'm numbering them as A, B, C, D. Excuse me. So the very first type are going to be the coin problem. So they're flipping a coin, heads or tails, you know. So heads or tails is what they will talk about. Next up, we will have questions which talk about the die. Either 1 or 2 or 3 or more dice are being rolled. And then the numbers, die is basically, I'll draw a little cube here for you. It's a little, sorry about that, it drew a long line here. I didn't mean to draw that, so I'll just go ahead and erase that line. And basically there are numbers here. You must have used a die in games and stuff, you know. So it has 6 numbers on all the 6 sides of the die. Next up, we will talk about the deck of cards. And total number of cards are 52. And then they also love to give questions that deal with different colored balls. All right, so with that taken care of, on my next page, I will let us see this fly away first. Okay, so we will talk about our very first type of questions, that are the coin questions. All right, so coin questions are basically, they will ask you the number of outcomes that can happen on a coin. So for this, I would like to give you an easy trick or a formula. The number of outcomes that you can calculate for a coin question, you can always depend on the formula 2 to the power of n, where n tells you the number of coins you have. So that means if I have 1 coin, then how many in total number of outcomes I can have? 2 to the power of 1, which is 2. Now, what are these 2 outcomes? If I'm flipping just 1 coin, I'm going to either have a heads or a tail. All right, let us see if this holds true for a question where I have 2 coins. So if I have 2 coins, my formula changes to 2 to the power of 2, which is 2 to the power of 2 is 4. I should have 4 outcomes if I'm flipping 2 coins together. Let us see. Either I could have heads and heads on the 2 coins, or I could have tail and tail on 2 coins, or I could have heads and on the first, tail on the second. And then I could have tail on the first, head on the second. There is no other outcome I can think of when you're flipping 2 coins together. All right. Now, this should be easy now for you. If I'm flipping 3 coins together, I'll have how many total number of outcomes? 2 to the power of 3, which is 2 times 2 times 2, and that is 8. So I should have 8 outcomes if I'm flipping 3 coins together. Let us see if I have 8 outcomes. So 8 outcomes, I think I'll have a very long parentheses here. So I'll have 3 options. I'll start with H, H, H. And then now is just playing. I usually like to do H, H, H and T, T, T here. So either I can have all heads and all tails. And then I can have, different options available. H, H, T, H, T, H, H, T, 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 H. Oops. I should erase that. There. All right. So H, T, T, and T, H, T. Let's see. 1, 2, 3, 4, 5, 6, 7. I'm missing one more. I should have 8. So, yes, the other one I don't have is T, H, H. So these are the only outcomes that can happen whenever I have 3 different coins. And always, any number of coins they give you, a very easy way to calculate the number. Because, see, the number of outcomes is always your denominator. So I can have 8 outcomes when I have 3 coins. I can have 4 outcomes when I have 2 coins. Now, whenever they ask you a question, we have to read the question very carefully because they will ask you questions like, okay, let us see, we are going to right now take into account our 2 coins that we are flipping. So if I'm flipping 2 coins, they can ask me a question: what is the probability of getting at least one head? Now, see, the trick is with reading the question well, because at least one head means I can take 2 heads into account also. So that will give me this option will work, this won't work, they both are tails. This will work and this will work. So, how many total outcomes do I have with 2 coins? 4. And how many favorable outcomes are there according to the question? 3. So, the probability of that happening is 0.75. So I hope it makes sense. Now let us say they ask you something similar, but now they're changing their words. So they can say, okay, what is the probability of getting one head only? So that means when you're flipping the coin, your answer should have the favorable outcome should only have one head. Now with that, I will not be considering this one because it's both of the flip answers are heads. So all right, so which ones will work for me? Total number of outcomes again is 4. And then I am looking for 1 heads. So 1, 2. So 2 over 4, which is 0.5, is the favorable outcome. Now, again, I repeat, they ask you questions, they try to trick you. The good deal is to first figure out how many total outcomes we have and then pay close attention to their question. Are they asking you at least or are they asking you specific? All right, with 3 coins, they can ask you a question like, let us do it right here. With 3 coins, they can ask you, I have 8 outcomes, so total is 8. And let us say their question is, when do I only have one tail? So one tail, I have all my sample space listed here. Where do I have one tail? 1, 2, and this one has 2. No, I can't take that. 3. So if I go through all of my sample space, there are only 3 favorable outcomes for one tail. So hopefully it made some sense to you. They usually ask you at maximum at this level, with 3 coins maximum. I don't think they'll go higher than that. All right, so on the next page, I'm going to deal with my option second, which was the type of questions are related to die. Like when you're playing games, you know, you use it to have different numbers. So let us see this fly away. All right, with that gone, let us have our option B. Now we'll discuss it, and that is called when we are rolling a die. And then I'll just try to make a nice picture of die for you. So just throwing some numbers there, but all the 6 faces of a die are 6 numbers. So I'll teach you an easy formula here as well. The total number of outcomes in a die. There is a formula. Like we had for coin. How many faces did the coin have? 2. How many faces does a die have? 6. So in order to calculate the outcome, I'll have 6 to the power of n, where n is the number of dice I have. So let us say I am looking at one die right now. So how many possible outcomes I can have? 6 to the power of 1 or 6. And what are those outcomes? Sorry, I'm still in the coins right now and thinking heads and tails. All right, let me have it ready for you. So I can either have 1, 2, 3, 4, 5, and 6. So, what could be the type of questions that they could ask us when I'm just rolling one die? All right. So, the type of questions they can ask me is okay, what is the probability of getting numbers, just odd numbers? So, if they're asking me odd numbers, I'll take 1, 3, and 5. So, out of total number of outcomes that are 6, my favorable outcomes are 3, which I can simplify to 1 by 2 or 0.5, or there is a 50-50 chance of getting an odd number. All right, with that taken care of, let us say if we have 2 dice. So 6 to the power of 2, there was 1 die. Now I have 2 dice. 6 to the power of 2 will give me the total number of outcomes, which will be 6 squared, which is 36. Oh, wow. So now I'll have 36 different outcomes. And what is the sample space of that? And with that, I want to get done with even if I have 3 dice. Although at this level of algebra, they will not ask you a question with 3 dice. Why? Because the total number of outcomes are 216. So that is going to take pretty much your whole hour of math class, you know, to figure out the answer. So we will just discuss up to 6. How is it 36? Let us see our sample space. So I'm going to draw a big old section here just to explain to you as to why we'll have 36 different outcomes. So see, if I'm rolling 2 dice, I can either have 1 and 1, 1 on first die, second on 1 on second, 1 and 1, 1 and 2, 1 and 3, 1 and 4. So I'm listing out all of my possible outcomes for 2 die questions. 1 and 6. Next up, 2 and 1. I can have 2 on the first, 2 on the second. Like this, I'm listing out all my outcomes for 2 dice. Now 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. I cannot go further than 6, remember. Now 4 and 1, 4 and 2, 4 and 3, 4 and 5, 4 and 6. Next up, we are almost there. 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6. Now, either I can have 6 on the first die and 1 on the second die. 6 and 2, 6 and 3, 6 and 4, 6 and 5, and 6 and 6. So let us see how many these outcomes are. Let us count the rows and the columns. 1, 2, 3, 4, 5, 6. And then columns are 1, 2, 3, 4, 5, 6. So 5 rows, 5 columns, sorry, 6 rows, 6 columns. I have 6 times 6, which is 36 different outcomes. So the type of questions they can ask me is, okay, what is the probability when I'm rolling 2 dice will have same numbers on both the dice? So that's how they ask you a question. They put a P and then the parentheses. All right. So when they ask me this same number on both dice, which will be my answer? This diagonal section here on my sample space is going to be my answer here. So 1 and 1, 2 and 2, 3 and 3. How many are there? 1, 2, 3, 4, 5, 6. So my answer will be 6 over. How many total outcomes are there? 36. Now, if I simplify, my answer is 1 over 6, and that's my probability. Not very likely, it's less than equally likely. So I can say it's unlikely that I can get that. All right, what could be a different question they could ask me? Okay, what is the probability of getting a sum of 10? That means the two numbers that I'm getting when I'm rolling two dice together is going to be the addition of the both the numbers is going to be 10. So let us list out those choices. If I see 6 plus 6, that is 12. This is 11. So I have found one of my favorable outcomes. Total is 36. One of my favorable is 6 plus 4, 10. What else is 10? So I'm going through all of this. 5 plus 4 is 9. There we go. 5 and 5 is a 10. 5 plus 6 is 11. I can't use that. Next up, this one will work. 6 and 4. If I go through all of my sample space, students, I do not find any other option available for 10 as a sum total. So I found three choices, 1, 2, 3. I can say, well, my answer is 3 out of 36, which is 1 over 3 times what is 36? 12, which is 1 over 12, which could be a really small decimal value. So this is also unlikely that this can happen just by looking at the probability value. All right, so this was about the die, students. Again, remember this formula. 6 to the power of n will give you the number of outcomes for a die. All right, let us see this go away. And we will start with our next option. Our next option, number C, is also starting with a C, which is cards. All right, on this one, I'll just give you a little option, little explanation about the information on cards, which we all, have played cards or we have cards at home, but the important things we at times don't remember. So here we have to understand that the total number of cards are always 52. And there are four major categories in the cards. All right, so I will have red color for the heart is red, and then there's a diamond shape. All right, I will just, the next one is black. So let me change color. Next up, our black is spade and club. These both are black. And these two are red. So there we go with our four categories, students. And then for every category, I have 13 cards. I would just like to color code it so it makes more sense to you. And we will start with every card. The number A or the first card is usually denoted by A or ace. So everyone has an A. All right, next up we have just the simple numbers, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, we have the J for Joker, Queen. I guess I can't write here, so I'm going to write right next to it. Hope you can understand. So 10, 11, 12, 13 is what they stand for. King is for 13, 12, and this is 11. All right, we still have red going on. I'll continue with the red only. Same thing goes on for diamond. 5, 6, 7, 8, 9, 10, J, Q, K. Alrighty, I'll take the black now. 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. All right, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, J, Q, and K. So this is my sample space for any card type question, students. And they can ask me questions like, okay, sorry, I forgot to tell you something important. So anytime they ask you red cards, we go by the color, black cards, we go by the color. One important thing that I really want you to understand here is that these J, Q, and K are called face cards. And then how would they ask you their question? They can ask you their question like, okay, what is, from a deck of cards, what is the probability of getting a red card? So this is a very, general question. So total number of cards comes as a denominator, which is 52. How many red cards do I have? I have diamond as red and I have the heart as red. So total of red colored cards is going to be 13 plus 13, which is 26 over 52, which is 1 by 2. And that is 0.5. That means I have equally likely chances of getting a red card as I have for the black one. Another type of question they can ask me is, okay, what is the probability of getting a face card? Now, face cards, how many I have total? I have 1, 2, 3 here, 3 here. So 3 face cards here, 3 face cards here, 3 here, and 3 here. So that means total of how many? 12 face cards I have out of the deck of how many cards? 52. So I can simplify that and give that as my fraction. That is going to be my um, probability of face cards. Another type of question could be that, okay, what is the probability of getting an ace? Now, in my deck of cards, which is total is 52, how many aces do I have? 1, 2, 3, 4. So with the probability of getting an ace is 4 over 52, and which will be a low decimal value. And that means it's unlikely that I can get an ace if I pull out a card out of a shuffled cardstock. All right, with that taken care of for card type questions, let us move on to our questions that are commonly asked, which is our last option here. Let us see this fly away. And our last option, I know this video is really long, thanks for bearing with me, and which is going to be balls, question that deals with different colored balls. So we'll have a box going here, students, usually in a question, that's what they give you. And they say, you know, that there are 4 red balls. We have 5 black balls. And we have 3 blue balls. So for questions like these, always remember the total number of balls is going to be going into your denominator. So here in this question, how many total balls do I have? 5 plus 4, 9, and then 10, 11, 12. So total number of balls is 12. All right, so let us see, our questions could be, what is the probability of, when I'm trying to pick balls out of this box, what is the probability of getting a blue ball? So the probability of getting a blue ball is going to be total number of balls 12. How many blue do I have? 3. 3 over 12, or 1/4, or 0.25, which could be, I can say, unlikely, something less than equally likely on the probability number line. Okay, that was my first question. I'll move on to second. What is the probability of picking a red ball out of this? So picking a red ball, I have, how many red do I have? 4. So it will be 4 over 12, which is 1 by 3, which is 0.3 repeating. Next up, they're asking me what is the probability of either picking a red or a black ball. So for questions like these, students, usually I add how many red and black I have. Red balls I have 4, black I have 5. So it'll be 9 over 12. Total number of balls 12 at the bottom, 3 over 4, which is 0.75. So that means it's a high probability here that I can either pick a red or a black ball. So hopefully it made some sense, students. And again, in this video, we talked about 4 different types of questions they ask us. And the first one was coin. Second was die. Third was cards. And the last one was balls. But again, this is not just a limited list. They can ask you more different types of questions, but these are just the common ones I wanted to deal with. This should take care of a lot of your probability questions. So hopefully it was a learning session for you. If you find a mistake, do let me know. And thanks for taking excellent notes and supporting this channel. Have a good one. Bye.